Namaste. Today in the Midha JEE channel, I am going to discuss a question and its solution which is related directly to the syllabus of class 9th and 10th and maybe to some extent to the syllabus of class 11th and 12th. So such kind of questions cannot be asked in the JEE exam directly. But the beauty with which such solutions can be designed must be looked upon by all the candidates who are preparing for the JEE exam. Because the more you see and the more you understand these kind of questions and the solutions, the more your thought process will also evolve. And you will definitely gain some perspective as well. It's a very classic question. Can an irrational number raised to the power of an irrational number be a rational number? Some of you might already be aware of this question. You may have encountered this question and you already know the solution. Even if that is the case, this video still has a lot to offer. Because not only I'm going to give you a comprehensive solution, I'm also going to analyze that solution so that I can make it better. Apart from that, I'll try to give an alternative solution as well. So let's start. This is my proposition. There exist two irrational numbers, a and b, such that a to the power b is a rational number. So before we start, I'm going to make an assumption. The assumption is that you already know that square root of 2 is a irrational number. You are already aware of this. You all have seen and done the proof in grade 10, grade 9, where root 2 was first assumed to be a rational number. It means it could be represented in the form of p over q, where p and q were co-prime integers. Now using some algebraic manipulation, we proved that there was a contradiction, which means that our initial representation of p over q is wrong. So we can conclude that root 2 is a irrational number. So our initial assumption of root 2 being a rational number is also wrong. It means we can conclude that root 2 is a irrational number. So if you know that, now consider this number. Square root of 2 raised to the power of square root of 2. Irrational, you already know this is irrational. So irrational to the power irrational. Now since we don't know the exact nature of square root of 2 to the power square root of 2, whether it is rational or irrational, we don't know. So there can be two cases over here. Case 1, that root 2 to the power root 2 is a rational number. That is case 1. Now if this is the case, then we are already done over here. Because this is what we were trying to prove in the first place, right? So we don't need to proceed further. But what if this is not the case? What if root 2 to the power root 2 is a irrational number? If it's an irrational number, then what we do is, we take this complete irrational number, root 2 to the power root 2, and we raise it to the power of another irrational number. Which one? Again, square root of 2. Now you apply the power rule of exponents. What was the power rule of exponents? A to the power of m to the power of n was nothing but a to the power of m times n. So we'll apply that power rule over here. We get square root of 2 to the power square root of 2 whole raised to the power square root of 2 is equal to square root of 2 raised to the power square root of 2 times square root of 2, which is nothing but square root of 2 whole square, which is 2. So 2 is a rational number. So we have proved that this is possible. There can exist two irrational numbers such that irrational to the power irrational is a rational number. Now this proof may sound very simple, quite elegant in fact quite cute actually. I'll call this proof very, very cute. But still some of you might be very frustrated and troubled actually. You might feel that yes, we have proved what we wanted to prove, that there can exist such two irrational numbers, so that if we raise irrational to the power irrational, we'll get a rational number. Even if we have done that, we are still not sure about the intermediate number, root 2 to the power root 2. What is the exact nature of this number? We still don't know. So this not knowing of the exact nature of root 2 to the power root 2 might be troubling you guys. Now in the beginning, I told you one thing, that I'll try to analyze this solution to make it even better. Now before I do that, let me try and propose an alternative solution. So I'll try to find another pair of irrational numbers a comma b such that a to the power b is a rational number. And this time I'll make sure that we are certain about the intermediate numbers a and b. Whichever numbers we are using, we are 100% sure about those numbers, whether they are rational or irrational. So let us try and give an alternative proof. Now before I do that, let's just revise two key properties which will be used to provide this alternative proof. The first property is with respect to the inverse relationship between the exponential and the logarithmic operations. Now exponential and logarithmic, whether you consider exponential functions and logarithmic functions or at the operational level, operations, exponential and logarithmic operations are inverses of each other. So it means that exponents and logarithms with the same base, they will actually cancel each other out. Just like multiplication and division. If you multiply and divide by the same number, they tend to cancel each other out and there is no change. Similarly, addition and subtraction. If you add and subtract by the same number, there is no change. They cancel each other out. So exponents and logarithms, if you see, you have exponent p, this is p to the power log x to the base p, base is same, they'll cancel each other out, the end result is x. So p to the power log x to the base is, log x to the base p is x, that is the first property. Second property we are going to use is log x to the power a is equal to a log x. Of course, both sides the base is same as b. So it means that if you have log x to the base, x to the power a, this a will actually be coming here and getting multiplied to log x. So these are the two key properties that we are going to use to propose our alternative solution. So let's start. Let's see what is the alternative solution. Now consider two numbers. The first number a as square root of 2 again. This we already know is a irrational number. The other number, let's consider b as log 25 to the base 2. Now this number, let's first prove that it is an irrational number by the method of contradiction. So to do that, we'll assume that log 25 to the base 2 is a rational number first. So we'll do this by the method of contradiction again. So we are assuming that it is a rational number, which means that it can be represented in the form of p over q, where p and q are co-prime integers. Okay. Now using the definition of logarithm, we'll get 2 to the power p over q is equal to 25. This is the definition of logarithm. Raising both sides to the power of q, we'll get 2 to the power p over q to the power q is equal to 25 to the power q. Now of course this will get multiplied p over q with q and q will get cancelled out. So on the left hand side you will have 2 to the power p, on the right hand side you will have 25 to the power q. Now 2 to the power any integer, p is an integer, q is an integer, 2 to the power any integer will always be an even integer without any doubt. But 25 to the power any integer will always be an odd integer because the end number, the end digit, the last digit will always be 5. So an even number can never be equal to a odd number. So it means that there is a contradiction over here. Contradiction over here. Okay. So if there is a contradiction, it means that our initial assumption of log 25 to the base 2 is equal to p over q is not correct, which means that it is a irrational number. It is not a rational number. Okay. So we have proved that this is a irrational number. We already know that root 2 is also a irrational number. Now let's take root 2 irrational to the power irrational, log 25 to the base 2. Now we'll apply those key properties of logarithms which we used. So what we'll do is, first we'll write root 2 as 2 to the power half. Log 25 to the base 2 we'll write as log 5 square to the base 2. Okay. Now, as I told you earlier, the second property was that this 2 will get multiplied and it will come over here. So, and of course the power rule will be used so that half is multiplied by this whole thing. So it means that this will become 2 to the power half times 2 log 5 to the base 2. Half times 2 cancelled out, it becomes 1, and this becomes 2 to the power log 5 to the base 2. first property which I told you earlier about, that exponents and logarithms with the same base will cancel each other out. So 2 to the power log 5 to the base 2 is nothing but 5. So now we have proved that irrational to the power irrational, there can exist another solution also where irrational to the power irrational is a rational number. 5 is a rational number. So we are very sure about this. Now let's come back to the first solution. I told that I'll try and analyze that solution. So let us come back to that. Let us analyze that solution. So this was the proposition in the my initial proposition, sorry. There exist two irrational numbers a and b such that a to the power b is a rational number. There were two cases, right? Case 1 was that we assumed it is a rational number. Case 2 was that we assumed that it is a irrational number. So let's call this as proposition P. Let's call this proposition P. And let's call this case as statement Q. This is statement Q. Of course, if this is statement Q, what will be this? This will be not Q, because if this is true, this is not true. If this is true, this is not true. It means that this is given by not Q. So I'm using some notations from mathematical reasoning chapter of grade 12. So if this is Q, this is not Q. Now let us analyze this. If Q is true, it implies P is true, because if this is true, then obviously this is true. But if not Q was also true, even then we proved that P is true. So it means that I can say that Q implies P. It means if Q is true, P is also true. And if not Q is true, then also P is true. So in any case, P is true. This implies that P has to be true. So if you analyze the solution properly, if you analyze these cases properly, then even though you don't know the exact nature of the intermediate number root 2 to the power root 2, still by this logic of mathematical reasoning, you can clearly prove this, that statement P is always true. Okay, now just some information I would like to give you towards the end, because still we haven't solved the mystery. What exactly is the nature of root 2 to the power root 2? We have discussed a lot of things, different examples, but this answer, this definitive answer is still not there with us. Now I would just like to tell you that root 2 to the power root 2 is actually an irrational number. In fact, it is a transcendental number. Now that is not in the course of JEE or 11, 12 or 9, 10. So we are not going to discuss that at all. It's a transcendental number because actually the two constituents of that number, root 2 and root 2, they satisfy the premises of the Gelfand-Schneider theorem. This is just for your information. Okay, it's a transcendental number. That's it for this video. I hope you liked the video. I hope you understood everything. If you have liked this video, please, if you like this video, please subscribe to our channel. And we have another channel where we teach students of class 6 to class 10. That channel is Mida Guru. Please go to that channel also. I hope you like the videos of that channel also. Please subscribe to our channels, and we'll definitely try and continue to bring such videos to you. Thank you so much. Namaste.